All right. Hello, everybody. Welcome to our June product peek with us here at Braincube. My name is Danielle Rand, and I have the pleasure of introducing you my colleague, Manuel Depot, a
Hello,
senior,
Daniel.
hello, a senior sales engineer with us in EMEA. We are really excited to have you with us today. We're going to take you through a quick, about 15-minute tour of Braincube, give you an inside look at the platform and some of the applications. And then we'll save a few minutes at the end for questions. And just as a reminder, please use the chat to let us know if you have any of those questions, and we'll get to them at the end. So with that, I'm going to hand it over to Manuel.
Thank you, Danielle, for the introduction. I'm Manuel. Pleased to meet you all. So before we get into the topic of today, which is about optimizing the processes with Braincube, I will share just a few slides, very short introduction about who is Braincube and what does Braincube do as a company. And so I'm sales engineer in the EMEA, as Danielle, you said. Who we are. Basically, we are an AI software company, and very important, we are dedicated to the world of industry. The Braincube platform, because we develop a platform, is aimed at optimizing the production lines by taking advantage of two things. Those things are the untapped process data and the power of AI. And so you need to understand that basically the mission of Braincube is to help every factory in the world to operate at peak efficiency. That's the mission that we are in. We are at a very exciting time in the company. We have more than 300 customers right now. The company was founded in 2008. It's about 15 years ago. We went through two series of funding, the first in 2018 and the second one very recently in November 23. We raised about $100 million. The idea behind is to develop an even better solution for our customers. We estimate that we have helped our customer base to save about $10 billion in the last 10 years. So it's a huge figure, and that is reflected in the ROI that we provide to our customers. So we are recognized as the company who is able to deliver, basically, and the analysts are saying the same about us. In particular, the Gartner has identified us as the only challenger in their 2014 the 2024 Industrial IoT Magic Quadrant. That's another achievement, but the most important achievement is, of course, the return that we get from our customers. Just before we move on in the demo, I'd like to introduce you the platform. What does it do, basically? What we do not provide, because we are, like we said, a software company, we do not provide the data sources. The data sources are part of the customer ecosystem. They can be of two kinds, mainly OT, operational data sources, and IT data sources. So we are able to connect to ERPs and application and files, but also machines, PLC, and so on. But the rest of those, let's say, layers are provided within the Braincube platform, meaning that we are able to connect to those data sources via different connectors that we provide. We are able to serve shop floor applications like shop floor monitoring, alerting, early drift detection. But I will not go on and on for each of those layers. The important thing to note is that basically we deliver value at each of those steps. And today we will talk about the ultimate step, which is the origin, but still the biggest probably value of Braincube, which is the advanced analytics features of Braincube. In that layer, the layer which is displayed here, the layer 6, we take advantage of the digital twin, which is basically the transformation of the raw data that we extract from the machines and systems. And by doing so, we are able to find correlations in the thousands, of variables that make up a system, an industrial system. So that's a very short description of what we do basically as a company and as a product. And I will switch to a demo just now. And obviously, if you have questions at the end, you can raise your question. We will answer you with pleasure. So I will switch now to the platform itself.
Manuel, just really quick, there's a comment in the chat just around more information about our digital twin. So maybe just as you flip into Braincube, you could kind of speak to our twin a little bit in some of the platform.
Could you repeat a bit?
There's a question in the chat about our digital twin.
Yeah.
So just as you're inside Braincube now, pointing
Sure.
out some ways, use cases, how it works, I think would be helpful.
Okay, sure. So I basically the digital twin, the Braincube digital twin is a model of representation of the data that allows to realign all the time series data, the discrete data that we have, and this is a way of representing the process of a production line that allows us to then find correlations. So it's not a physical view, it's not a 3D view of a machine or a process or a production line. It's like an identity card of an object or process that is linked to manufacturing. So I'm connected to, I will switch to full screen now. Today, we'll take the example of an energy consumption. We take the example of a boiler for which we want to decrease the natural gas consumption. So basically, this is a very typical boiler that we find in different industry. In particular, we find this kind of boiler in the food and in paper, but in many situations, we have this kind of process. So we have a boiler that takes into for its combustion that takes natural gas, biomass, wood. It takes oxygen to boost the combustion, and we are also able to purge the air within the chamber of combustion to adjust the combustion. So as you all know, the energy is an issue. The price of energy is rising a lot. So it was asked to study the boiler combustion to decrease the amount of gas that is needed to run that boiler. So we have made a dashboard with Braincube. All we see here is the Braincube platform. We have made a dashboard and a chart about the consumption of gas of this boiler. And what I will show you now is how you can directly from such a chart with Braincube find correlations between all the variables that make up a digital twin to optimize that combustion. So this is a graph, a chart that is made up with Braincube. I don't want to dig in all the features that are permitted within this interface, but I will focus on directly from that trigger what we call an analysis, a correlation analysis to optimize that combustion. I will create, for the sake of this demo, a mono-objective analysis, which is basically to reduce that consumption of gas. I could do something much more complicated, like decreasing that consumption, but also reducing at the same time the CO2 emissions, for instance, but I will keep it simple. And as you can see here, I've got a wizard that allows me to do so very simply. I'll go from the chart. I am guided along the process, so I can keep the same time period. I can keep the same conditions. In this case, I only consider the data where the boiler was operating. I could avoid specific times in period in time where I had specific events that would have a bad impact on my data. And I will set my objective directly from that wizard. In this case, I want to reduce the consumption, so I will put a maximum. And for the sake of this demo, I will put myself as an objective at the median. I had that objective. And so I split my data set in two parts, the red points, which are basically over the objective that I want to set, and the green points are under that limit. This way, I've got 50% of each category. And when at the end of the day, the tool will propose me an improvement, will indicate me a possible lift, I will know what it corresponds to. Basically, if I get 100% lift, it will mean that all my red points would have been converted into green points, meaning that they would get under that limit of 1,254 normal meters cubed per hour. So I let the wizard propose me all this optimization. Then I select which variables among all those hundreds or thousands of variables I want to find correlation within. In this example, I've got 784 variables, which is quite a lot. I've got a period of time of about 6 months. But I could let the tool run against all these data sets. I could also make some selection between those variables because I just want to look at the variables where I can have an impact on, like controllable variables. So I've got different options to work. In my case, I will select a group, which is a group I know that are controllable variables. And I've got 760 variables in my case. I will let the wizard propose me a name for that analysis. I will make that analysis private or public. In this case, I can keep it private. And I will trigger just now the analysis. So I've got about 6 months of data here. I've got, in fact, about 16,000 points. Okay. I've got 700 variables, and it takes like, let's say, 15, 20 seconds to run. And you'll see how powerful this is at the end. So this is a reminder of my baseline I just set with you. And the execution of that analysis is just here. I've got about, like I said, 700 variables here, which are compared to my natural gas flow output variable that I want to optimize. And so I've got different options here. I can see that I've got the stability of the chamber, which is indicated as a parameter that is important. I've got the input of O2. I've got the purge air compressor value. So I could decide to investigate where I was in those variables. So if I take this one, for instance, the O2 flue gas, if I open it, I get a specific chart. Okay, and that indicates me where I was in my historical data set. My setting about the oxygen was between 2% and 40%, 14%. And in fact, what is interesting here is that the main setting, when I was between 4 and 5, had been used many, many times compared to the rest. And in fact, that setting was inducing poor results. The red bars indicate, in fact, a negative impact on my results. So the tool is telling me here that I should have been over 5 to have a positive impact on the combustion. So that's the first insight. I can create a rule directly from that and let the tool work on the other parameters. So I've got a rule which is setting the oxygen setting about 5.12 to 14. I say, okay, this is a a good finding. I go back to the list of parameters that can be adjusted, and I will take a second one so you can see the combination. Sorry, I took the same, so I will go back. Excuse me. Trying to go fast because we only have a short period of time. We don't want to consume too much of your time in the afternoon. So I will open a new one, another one, which is the level of purge of the air. And I see here another insight. I had 3 settings which were used by the operators. I was between 59 and 78, and 3 different settings used by the 3 different shifts probably. And the tool is telling me about the same. It tells me that I need to be between 59 and 73. When I go over 73, I induce negative impact in my results, in my gas flow consumption. So I will create a second rule based on that. Okay. I'll go back to the list. I could go on and on all the variables that I find impacting and interesting to adjust. And I could also just stop there and say, okay, I've got 2 ways of improving my gas flow consumption. So I will investigate those 2 ones. I will combine those 2 to create a combined rule. Braincube has this capability to make multivariate analysis. And I will look at how this could improve my settings. So basically, the analysis is telling me that those settings were encountered 32% of the time in my history. That's cool because I know it's not an exotic situation. I will be able to reproduce that. And it's telling me that my average, which was 1,191, could be down to 839. So I would have reduced my consumption by an order of magnitude, which is very important. And this is indicated here. It will be reduced by 73%. I started with a split at 50%, and at the end I will be at 80 and more percent. So I've got a first way of optimizing my natural gas flow consumption, and this was done just in a few clicks, basically. Once the data is prepared in the digital twin, which will be the topic of another product peak, I can do analysis in just a few clicks, so I can run different analyses. In 1 hour, I could do a lot of different analyses. I could run and try to find optimization this way. And so you can accelerate the way you transform your process very easily. So right now, because we are already short in time, I will go to I go back to the presentation. I hope you can see again. Daniel, if you can confirm.
Yes.
Thank you. And so that was a very a rapid overview of the optimization capabilities of Braincube. In practice, this, as you may imagine, is a summary, a synthesis of a use case, practical use case that we had a lot of time with in the paper industry. In the paper industry, like we introduced the demo, we do have biomass boilers. And so at a customer, we were asked by a customer to help them optimizing such a boiler. The situation was that there was a boiler, biomass boiler, that was not performing at the expected OEE. The OEE was pretty low, between 40-42%. The stability was not there. And so the steam, which is used to transform the pulp into paper, which is used in this industry, was not stable enough to produce with a good profitability, basically. And that request from a customer also arrived at a time where CO2 emission regulations were reinforced. There was a new announcement about emission that needed to be reduced by 2030. And so the objective was to stabilize the process, improve the OEE, but still not raising, in fact, reducing the CO2 emissions. So how do we do in this case? The first thing we do, we connect to the data sources. We don't go right away in the optimization of the process. We first analyze the historical data. We look at the historical data. That's the first way to understand patterns, understand how the things are operating, how the things are correlated together, but just visually. And so there are insights, but it's because the phenomenon that we have in production are multivariate, as you know, that does not allow to do everything. So once we got this historical data visualized, then we used what we just showed in the demo, we used our cross-rank algorithm to find the best settings to operate the boiler. And those new settings were then pushed to the shop floor to help the operators to be able to react more quickly, to adapt to different circumstances on the shop floor. So in a period of time that was under a year, we got very good results. And that's the kind of use case that we can reproduce from in the wool industry. The yield got increased by 16%. Okay, it was around 42, and we raised it to 58%. We could make savings in the natural gas consumption about 1.2 million euro per year, and at the same time, we could reduce the CO2 emission by 30%. So that was a super achievement, basically. And the success of this kind of project also allows you customers to adapt a more data-driven approach. That's that part of the goal. So I'm sure that we are almost at the end of this time. So I will switch to you, Danielle, and to see if we have questions. Thank you.
We actually do have a few questions. One I see in the chat, when you were in CrossRank, we had a question, how much computing power is used to do the analysis?
How much computing power? Well, that is not exactly a problem because we the CrossRank algorithm work in the are hosted in the cloud, basically. So we use the power of the cloud, the elastic, what is called the elasticity of the cloud, to use the necessary resources that we need at that time. I mean, if it turns out that the power, the CPU power is too high, then we just provision another CPU engine, and that's we always get the results we need. I mean, we can work on thousands of variables. We have customers that use almost 10,000 of variables, so we don't have a real limit there. And we can work on historical data of 2-3 years. We are clearly in the big data, landscape.
On that note, when it comes to data, there was a question around how interoperable is Braincube with like other pieces of tech in the industrial tech stack. So do we integrate with the historian and MES when we were looking at all those data points in CrossRank? Can we bring in those from other data sources?
Yeah, definitely. Yeah, we went quite fast also on the types of data sources that we leverage, basically. In many projects that we have, we do have historians database, so we connect to those historian databases. And so a data source can be a very source of the data or can be a data aggregator, like an historian. So the response is that we connect to everything we have. Sometimes we don't have everything digitalized, so we can also use a data platform to digitalize manual processes. But most part of the time, we connect to data aggregators like MES, historian, and so on.
And then one other question here. Um, do I need data scientists to do the analysis that you did today? How kind of easy is it? I mean, I know you made it look easy, but there's a question around if data scientists need to be on the team to use Braincube.
Yeah, very good question also. In fact, Braincube was also thought not to be used by process engineers, people with a background coming from the industrial world also. So you don't need to be a data scientist to use Braincube. If you are a data scientist, the advantage of Braincube is that you will be able to combine all the interface that is thought by industrial for industrial, and you'll be able to integrate Python script or models that you have developed or you have retrieved from something from somewhere. So you can be a data scientist, but you don't have to. I mean, what I showed here was very powerful, and the algorithm which was behind was a Braincube proprietary algorithm. So if you are not equipped with a team of data scientists, you are not blocked with Braincube. That's at the origin of the product. It was thought for industry by industrial for industrials, but we don't
Awesome.
ignore this population.
Well, Manuel, thank you so much for your presentation, and thank you for all of our attendees for joining us today. If you have any follow-up questions, please feel free to reach out to Manuel or to us directly. We're here to answer your questions. And please join us for our next product peek, which will be next month. We do these monthly. I'm actually seeing one more question that just came in through
Sure.
the chat. Um, is the algorithm the same on all of your projects?
What we just saw here is one algorithm as part of many that we do have in the platform. In fact, because um, there is some various situation, but the multivariate correlation analysis is what we saw here. So we can reuse this algorithm in many projects as long as you have prepared the data in the right way, of course.
Which could
Yeah.
almost be its own product peak is the data preparedness, connectivity, treatment piece as well, since that's a big part of this. Well, with that, I think thank you so much again, everybody. Thanks, Manuel.
Thank you.
Thanks to
And if you
everybody
have
who joined.
And if you have other questions, feel free, of course, to push them to us, and we'd be very happy to inform you, to respond to you. Sure. Thank you.
Thank you so much. Have a great rest of your day.
Bye bye.
Bye bye.